In this video, we're going to continue Lesson 6 of Unit 3, Solving Radical Equations. We just practiced finishing several of these. Now we got a fourth one on that same page with a couple of cube roots to solve for. So in this case, when I have two radicals in my equation, I want to be able to get rid of both of them. Now, if I were to, at this moment, cube both sides, I'd have a big old mess because cubing this would mean take this binomial expression times itself, which would be a whole lot of FOIL that I don't care to do. So the key when I've got multiple radicals is I want to split them up. Let's get them one out radical on one side and one on the other. So we're going to add the cube root of 8x plus 15 to both sides. It gets rid of it over here and then just adds the same thing over on this side. So what I have now is I've got a cube root on the left, the cube root of 12x minus 5. And that's equal to the cube root of 8x plus 15. Now you probably know where this is going. Now that I have at least one radical isolated on one side of the equation, I will then get rid of that radical. So if it's the cube root, I'll undo that by cubing this side. And if I do that on one side, do the same to the other. Cube a cube root makes it go away, leaves it with just the inside, which is 12x minus 5. And the right side is conveniently also a cube root, which goes away when I cube it, leaves me with just the inside, which is 8x plus 15. Now I have a nice linear equation. This one's pretty easy to solve from here. Combine the x's by subtracting 8x from both sides. Combine the constants by adding 5 to both sides. And that will leave me with 12x minus 8x is 4x. Negative 5 plus 5 is 0. It cancels. 8x minus 8x is 0. That cancels. 15 plus 5 is 20. Last step, divide by 4. And x must equal 5. Plug it back in to check it out just to make sure. 5 times 12 is 60. And 60 minus 5 is 55. So I have the cube root of 55 here. 5 times 8 is 40, and 40 plus 15 is also 55. So I have the cube root of 55 minus the cube root of 55, and yes, I'm going to say that does equal 0. So that'd be solving when I've got a cube root or multiple radicals in an equation.